Good morning, students of grade 9. Today we will start our new chapter about mechanical actions. First of all, we will start about the definition of a force. The mechanical action exerted by an object on another object is represented by a force. As shown in the adjacent figure, a man is pulling a cart. This mechanical action done by the man on the cart is represented by a force F. The actor is the man and the receiver is the cart. As we noticed, the force cannot be seen, but we can notice its effects. So, the force has three effects. It can set an object in motion, or it can stop the motion of an object, or it can deform an object. The representation of a force. The force is represented by a vector F. The vector is an oriented segment as shown in the adjacent figure. A man in this figure is pulling a box under the action of a force F. This force F is represented by a vector as drawn in the adjacent figure. Every force has four characteristics. The first one is the point of application of the force. The point of application represents the point where the force is applied. As in our example in here, the force F is applied at the point A, so the point of application of the force F is the point A. The line of action of the force could be vertical, horizontal, or oblique. In our example, the line of action is oblique. The direction of the force could be upward, downward, to the left, to the right, or any direction we have. In our example in here, the direction of the force is upward to the right. The magnitude of the force represents the intensity of this force. It's expressed in Newton, its SI unit. In our example in here, the magnitude of the force is F equal 450 Newton. The type of a force. We have two types of forces, forces acting from a distance and the contact forces. The forces acting from a distance are three: the gravitational force, the weight, the magnetic force, and the electric force, while the contact forces are the muscular force, the normal reaction of support, the tension force, and the friction force. Now we will start discussing these forces. The weight force. The weight force is the force exerted by Earth on an object. Its characteristics are: the point of application of the weight force is always the center of gravity of the body, while the line of action of the weight is always vertical and its direction is always vertically downward. The magnitude of the weight force can be calculated using the formula weight is equal to mass of the body times the gravity. The mass must be expressed in kilogram and the gravity must be expressed in Newton per kilogram, while the weight, which is the force, is expressed in Newton, its SI unit. This weight can be measured using an instrument called the dynamometer or the spring balance. The magnetic force. The magnetic force is an interaction between two magnets or a magnet and a magnetic material, as shown in the adjacent figure. If the two magnets have the like poles, they will repel, while if they are unlike poles, they will attract. The force exerted by the magnet bar in this figure on an iron ball is the magnetic force. The electric force. The electric force is an interaction between two charged objects. We have two types of charges, a positive charge and a negative charge. If the two bodies have the same charge, they will repel, while if they have different charge, they will attract. In our example in here, a positively charged ball is attracted to the negatively charged rod by means of a force called the electric force. The normal reaction of support. The normal reaction of support is a force exerted by a support like a table or roof, a chair, on an object placed on it. An important note about the normal reaction of support is that it's always perpendicular to the support, so that if we have a horizontal surface or an inclined surface, the normal reaction of support in both cases is always perpendicular to the support. The friction force. The friction force is the force exerted by a surface on the object. The direction of the friction force is always opposite to the direction of the motion of the body. If we are moving on a rough surface, then we have a friction force. Why? If we are moving on a smooth surface, then we have no friction force. The first example in here, a box is sliding on a rough surface, so we have friction force opposite to the direction of the box. While in the second figure, a box is sliding on a smooth surface, so we have no friction force. The tension force. The tension force is a force exerted by a spring or a string on an object attached to it. This force will be discussed in the next chapter. The muscular force. A muscular force is a force exerted by a body, like a hand or a foot, on an object. It can be a pushing or a pulling force. Finally, this is a summary table showing the different forces, their types, the situation, their names, symbols, and line of action and directions.